right, good. Thank you very much. Yes, so we are here in the plenary. Plenaries are special, are very special, as we're discovering. But the PAS workshops that we're having are also very special. And they are just definitely also more than excellent science. They are more focused on a particular topic. But they also definitely do reflect on the role of science and scientists in society. And that's why I think the quote that we have on our PAS website from Pope Benedict is still very relevant. The passionate search for the truth about the cosmos, the nature, and also the constituents of the human beings. So astronomy is very much part of all of that. So as Brother Guy said, it's easy to relate to the general public, to every one of you, because every one of you is part of this world where about half of the time we are viewing, able to see the night sky. And that is also available to everyone, everywhere in the world. And so immediately it starts to raise questions as to where do we come from and what is our place in this universe. And again, there I'd always like this particular quote from Immanuel Kant that about the starry sky above me and the moral law within me, that are the two things that fill the mind with ever new and increasing admiration. So this really coupling of the starry sky above me and the moral law within me. Now, one of the workshops that we've held just recently is on the James Webb Space Telescope, the next big mission from NASA with participation from ESA and from Canada. And we named this indeed from first light, looking for the very earliest galaxies in the universe, to new worlds and new views also of those worlds. And this is one of the beautiful pictures that was released in July, the first pictures. I think the fungi will like this picture as well. It has a lot of blue in there. But everybody can download these pictures. They are all open data. Most of the data in astronomy are open to everybody in the world to download. So this is one of those projects that is not just a 10-year project, but is actually a 30-year journey to finally get to that launch and say goodbye to Webb as it is being departing there from the Ariane 5 rocket. Planning started in the early 1990s, and it's really thanks to thousands of engineers, technicians, and managers, and a few scientists that we have this wonderful golden eye, as we call it. So one of the topics that will be very heavily featured here in this session is not just our own solar system, our own Earth, but really planets around other stars. We call those exoplanets, and we now know that they come in a huge diversity, and that's thanks to the groundbreaking work that led to the Nobel Prize in 2019, and we're very fortunate to have Didier Queloz here with us. So we'll hear a lot more about this enormous diversity of planets, from very small Earth-like planets to very big Neptune and Saturn-like planets, but also planets of a type that we don't even have in our own solar system. And so the next step, that was step one, and if you take the equivalent of Eric Lander's, step two is now looking at their composition and habitability. Now, since water was mentioned so often during this whole conference, I thought I should show you a little bit the astronomer's view of how we think actually that most of the water in the universe and the water that we have here on Earth, the water that is in your body and that you drink here, was made. It's made on these tiny dust grains that are present in these clouds out of which new solar systems collapse. And once a day, a hydrogen atom lands and it finds an oxygen. It can make O2. It can make actually hydrogen peroxide that we heard about earlier today. There you see actually hydrogen peroxide being made, and then you make more water molecules. And now we speed up from a few days to a few 10,000 years. And this is the way that we actually make water in space, and that's the water that also gets to the planets. And that's also what came to Earth. So think about it the next time that you take a little sip of water. I'm drinking water molecules that are actually older than the sun itself. The original bonds were already formed some 4.5 billion years ago. Good, with that perspective, and also a little movie to wake you up after lunch, as Francis said earlier in the meeting, I hand it over back to Brother Guy for chairing the first part of the session.